Inside every MRI machine sits roughly 2,000 liters of liquid helium, chilled to -269 degrees Celsius, just 4 degrees above the coldest temperature physically possible. That helium is the only thing keeping the scanner's magnet superconducting. And here is the part almost no one realizes. That exact helium can never be replaced once it's gone, because it is the only element on Earth light enough to escape the planet entirely and drift off into space. We treat helium like a party trick, the gas that squeaks your voice and floats balloons. But that casual abundance hides a brutal truth. Helium is non-renewable in any human timeframe, and the global supply runs through a handful of facilities in just a few countries. When prices spike or a single plant goes offline, hospitals start rationing scans and physics labs shut down experiments. The gas everyone laughs about quietly underpins modern medicine. To understand why helium matters, you have to understand cold. An MRI builds its image using a magnet thousands of times stronger than the one on your fridge. To generate that field without melting, the magnet's coils are made superconducting, meaning electricity flows through them with zero resistance. But superconductivity only switches on at extreme cold, and only one substance stays liquid cold enough and stays inert enough to bathe those coils safely. That substance is helium. Why does helium escape the planet? It comes down to weight and chemistry. A helium atom is the second lightest thing in the universe, and it refuses to bond with anything, so it never gets trapped inside heavier molecules. Once it reaches the open air, it rises through the atmosphere faster than gravity can hold it. At the top, the slightest push of solar energy flings individual atoms past the point of no return. Every breath of released helium is gone forever. So where does our helium come from if it keeps fleeing into space? Underground. Deep in certain rock formations, radioactive elements like uranium and thorium decay over billions of years, and each decay spits out a helium atom. Trapped beneath impermeable rock, that helium slowly collects alongside natural gas. It is, in the most literal sense, fossil radiation, accumulated drop by drop across geological time. We are not mining a gas. We are mining the slow exhale of the planet's radioactive core. Here is the catch that makes helium so fragile as a resource. It is almost never worth extracting on its own. Most helium is captured only as a byproduct of natural gas processing, and only when the gas field happens to be unusually rich in it. That means helium supply is chained to the economics of an entirely different commodity. If a gas plant stops running, or the field's helium content is too low, that helium simply vents away or stays underground, no matter how badly the world needs it. For most of the 20th century, one country dominated this entire equation. The United States, sitting on top of a freakishly helium-rich gas field beneath Texas and the surrounding states, built a national helium reserve and stored the gas in a vast underground formation near Amarillo. For decades, this single reservoir supplied the majority of the world's helium. American medicine, American rockets, American physics labs all drew from the same buried tank. Then Washington made a decision that still echoes today. In the 1990s, lawmakers decided the government had no business hoarding helium and ordered the reserve sold off to pay down its debts. The gas was released onto the market at fixed, often artificially cheap prices. For years, this flood of cheap helium masked how scarce the element really was. The world got comfortable, demand grew, and the reserve quietly drained toward empty. By the 2010s, the consequences arrived in waves. Researchers called them the helium shortages, periods when prices doubled and suppliers placed customers on strict allocation. Hospitals worried about keeping their MRI magnets cold. University labs canceled experiments. Some balloon retailers were turned away entirely so that medical buyers could be served first. The casual gas had become a contested strategic material, and the country that once controlled it was now running on fumes. So who controls the supply now? The center of gravity has shifted across the world. Qatar, processing enormous volumes of natural gas, has become one of the largest helium exporters on Earth. Russia has poured investment into a massive new plant in eastern Siberia designed to capture helium from its gas fields. Algeria contributes a significant share. Suddenly, the gas that keeps Western hospitals running depends on a handful of producers, several of them in regions where politics can choke a pipeline overnight. That dependence is not theoretical. When a regional blockade cut Qatar off from its neighbors, helium shipments seized up, because the gas had to travel by sea through ports that were suddenly closed. When sanctions and conflict disrupted Russia, the West lost confidence in a supply it had been counting on for the future. Each event sent a tremor through the price of keeping an MRI magnet cold thousands of miles away. Helium is now hostage to geopolitics it has nothing to do with. The engineers fighting back have two real options. The first is to stop wasting what we have. Modern MRI scanners increasingly recycle their helium in sealed loops, recapturing the gas that used to boil off and vent away. Some newer machines need only a tiny fraction of the helium older models required. The second option is to find the gas before it's gone. Companies are now drilling specifically for helium, hunting underground pockets where it is concentrated without any natural gas at all. There's even a frontier where helium isn't running out at all. The moon's surface and the gas giants hold vast quantities of a rare variant called helium-3, prized for fusion research and unavailable in any quantity on Earth. But that is decades and untold billions away. For now, the only helium we can actually use is the slow geological dribble trapped beneath our own feet, and we're spending it far faster than the planet makes it. So the next time you see a balloon drift up and vanish into the sky, picture the chain it sits at the end of. A gas born from radioactive decay, trapped for 1 billion years, pulled from the ground as an accidental byproduct, hoarded and then squandered by one government, and now controlled by a few distant producers who can tighten the tap at will. It cools the magnet that may one day see inside your body. And once it slips loose, it doesn't just run out. It leaves the Earth completely.
If you found this deep dive valuable, hit the like button, drop a comment below on what tech mystery we should decode next, and subscribe to never miss an episode.